Welcome to our project, the boom cannon. Here we are filling up the tank with some air pressure.
Alright, with a barrel, we need to get a wadding, which I just get from paper towel right there. You put it in. This is to stop the ball from going into the valve. And then it goes all the way down, and you just screw it in, and it's loaded. Alright, to shoot this, we just pull the valve real fast, and I'll do that right now.
Alright, Mr. Richard, welcome to our masterpiece. First of all, here we got our different barrel lengths that we used in our experiment. Then we also got, for example, we used a fire hydrant tank to store the pressure. Here's the pressure valve where we added pressure to the tank. Here is our gauge to measure how much pressure we also have. Here is the pressure releaser that we use to, of course, release all the air pressure and shoot our little tiny marbles. Here are 3 connectors that connected our pipes, and yeah, that's pretty much it.
Go.
First of all, our first problem was a fire hydrant. We had to discharge it, and it caused a little bit of a problem. Anyways, so another thing we had to do was using this thread tape, we had to make sure there was no air leakage. The way we did that was putting our entire project in the pool, and then figuring out where all the air bubbles were coming out from, which told us where all the air leakage was coming out from. Then we just proceeded to add more and more thread tape, and which allowed us to have a lot less air leakage, to the point where we pretty much had none. And other than that, the project itself was very straightforward. It was really easy to put together, and we had no other problems besides having OCD problems to where we would put the pressure valve that we would add more pressure.
Hello, this is our cannon and the principles behind it. This is a pressure cannon. We fill up the tank with high pressurized air and use the pressure laws where high pressure likes to move to a low pressure system. And by filling this with high pressure, we get the force to push the ball by the gas wanting to move to a low pressure. In this project, we encounter equal and opposite forces, because when it pushes air out that way, the cannon also wants to move in the opposite direction. We solved speed by distance and elevation drop, and we did that by the distance drop, which is being x. We did x equals VOT plus 1/2 GT squared, and we cut that down to x equals 1/2 GT squared, because initial velocity is negligible because it starts at 0.
Here we have all of our data that we collected through a data table. Here we have our barrel length, our 3 trials, the average trials, and then the time and the velocity. And from this data table, we were able to conclude with a graph.
Conclude that we had an outlier with the 1-foot barrel. But the trend over the 2, 3, and 4 barrel was the velocity getting exponentially greater. Thank you for listening to our boom cannon experiment.